Okay, welcome back. We're having a look at the most important thing you can learn, apart from the 6 things: chain rule and integration by substitution. The 6 things: chain rule and integration by substitution. And if you have those things, I will almost guarantee that you will cope extremely well, perhaps passing even. Not only this subject, but Maths 1 and subsequently Maths 2. So please learn this as well as you have been learning the chain rule. The idea here is the nomenclature is quite hard to follow, and the proof I will do simply as a matter of bringing to bear in the video. Okay, so I don't mind doing that. What's important to recognise though is that in our work, we want to draw a distinction between doing our inputs and outputs and our work in analysis. The analysis work is important, but it provides a basis on which we can begin to take our journey into mathematical sciences in a deeper way. But having said that, we can't lose sight of what's important. Okay, so in doing this, I don't want to overstep the mark in terms of including you in the field of mathematics. So that's why I'm putting this here. So where we've got a particular integral, okay, what we will do is do this general one here. Okay, so we'll integrate. Algebraics is normally where it comes in, so this is extension 1 type work. With now the brackets are important. Look at that. The brackets are important. Okay, so we will let some value u equal ax plus b, and we will then differentiate that du dx straight away. So the important thing here is to stay in the column, and I'll repeat that again soon enough. Okay, normally we'll jump back over here and do some substitution, but I want to just stay here for the moment. And the b will go because it's a constant. Ax will just remain as a. So what I want to do now is I want to take the gist of why we stay in the column. So I'm going to multiply both sides by dx. So dx, dx. These will cancel because they're one in disguise. And we get du is equal to a dx. The next thing we're going to do is divide by a both sides. What you do to one side, you do to the other. They will cancel. So we're left with 1 over a du equals dx. Now, here's the thrust of it. Are you up in the original? There I am. Well, guess what? You're getting substituted out. You're getting substituted out by this du. I'm no longer going to write dx, but I'm going to write du. Now, most students coming to university are unable to get to that point. You'll notice that I've not put in the main part of the substitution because I've been focusing on stay in the column. And the importance of this is that students can't stay in the column and develop this substitution to the extent that they should. So I'll do the trivial bit now. So, of course, I've left a bit out here. Okay, I've left a bit out here. Okay, but what I want to do is bring that constant across because we saw that in the table of rules, that we can do that. And there's our reformed part. Now here's the trivial part. There was a bracket with n. The thing in the brackets was u, so we raise u to the power n. So this for me is trivial. What it's done is taken a more complicated integral and simplified it, which was the purpose of integration by substitution. Okay, leads to a simpler or more simple, a simpler calculus step. Okay. It leads to a more simple calculus. Because you'll agree, this is easy. How do I do this? Up and under. Oh, okay. So the integrand becomes 1 over a stays outside. U to the n becomes u to the n plus 1 up divided by n plus 1 plus c. So in effect, that is our solution. Okay? So if we look at what we've got up here, it's the same thing. So as required. Okay? We've given our solution. Now, you might look at this and go, what are you talking about? And I'm okay with that. I'm okay with you saying, what are you talking about? Okay? Because it's important for you to recognise that analysis in mathematics is hard. You heard me say it, the hard word. Most of it's not hard, what we've been doing. But every time I've referenced analysis, I've said it is hard. Because that's the hard part. Okay? Now, what you might notice is that for some integral function, we're looking for elements that we can substitute. This stay in the column. What are we substituting? Okay, what are we substituting? So what we do is we look for, to use substitution, we look for derivatives of some function raised to n. We look for the terms around it, right? The terms around it, which are in fact derivatives. Okay. Terms around, it could be in there. Terms around, which are derivatives. Okay, ddx. And then when we do that, we can invoke use substitution. So we'll do a couple that don't mean much, but we'll do some more that matter a great deal. Alright, so let's do this particular example. Okay, so we have a use substitution. The use substitution. There's brackets. So brackets are the reason why we do use substitution. No. We'll come down to that one. So let's do a couple of simple ones that seem a bit improbable. Okay, so we're going to let, this is very important, please follow procedure. I'm begging you. Okay, that u equal 7x plus 1. So do we run off now and rewrite like we did in the chain rule? No. Stay in the column. Okay. Leaving it. Oh, this was like the chain rule. You betcha. The difference is 7. Okay. Now I'll do it one time. But I'm not going to keep doing it. Okay, what are we subbing out? Dx. Are you up there? There you are. Guess what, Dx? I'm swapping you out. I'm swapping you out by writing this. I'm going to put the 1/7 out the front. Okay, again, most students coming to university cannot build that up. They can't stay in the column and get that done. Okay? Because what they did before was like they do in the chain rule. They rushed over here and wrote, oh, I can do U substitution. I can do U substitution. That's all I had to do. No, 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 no. Because they've been taught a shortcut. No shortcuts. We stick to it. Okay? Now we can do the integration because we've got all the parts. So it's up and under. So the integrand will become 1/7 stays U. 3 plus 1 is 4. under plus c. So we'll get 1 over 28. 4 sevens 28. U is 7x plus 1 to the power 4 plus c. And that's our final answer. Can I put the 7x on 4? Yeah, because it's a product. Well, it's a product. So you can write 7x plus 1 on 4 over 28 dx. Okay, can I do that? Okay. Yes, you can. Can you use technology to check it? Yes, you can. Okay, so let's have a look at technology. Does it do an integration as well? Integrate y f of x. Let's do f of x equals bracket 7x plus 1 to the power 3 dx. Take that, and I'm just going to take that bit, and over here I'm going to do a shorthand version. That I'm just going to call int. Let's see if it'll cope with that. Int with respect to dx. Same result, see? So whether I take it as a y or a function, it doesn't like y, it might play up a y with it. And it's got the shorthand notation int and integrate. Okay? So you can use your technology to check your answers. And I encourage you to do that. Encourage you to check your answers using. It's not cheating, it's being smart. Okay? Alright, so what we're doing then is U substitutions by integration. So they seem a bit meaningless at this point, because why are we doing, you said something about that. Well, 5x minus 2, stay in the column, du dx is equal to 5. Swap it all around. I've stopped doing that for you, haven't I? So, are you there to be swapped? I sure am. There you are. So go swap you out. Integral 1/5. Can you get to there? Most students coming out of General Advanced Maths in New South Wales, I beg to differ. Now, what's the square root? It's a half, isn't it? It's a half. So whatever was in the middle there is a half. Oh, it was u. U to the half. So let's do the integration. 1/5 up and under divided by a half plus 1 plus c. A half plus 1 is 1.5. I know. You thought I was being funny, didn't you? Okay. 1 plus 2 on 2. 3 on 2. So we end up with 1 on 5. U 3 on 2. Divide by 3 on 2 plus c, which equals 1/5 u to the 3 on 2 times 2 on 3 plus c, and so finally we get 2/15. And u itself was 5x minus 2. We could write that as the square root of 5x minus 2 cubed plus c, capital C. So either form would be okay by me. You'll need to pay attention to instructions to know which form to put in. Alright, so making a big drama again, Jason, about procedure. When does it become an advantage to us? Well, here it comes. Okay? The advantage comes here. So we'll do these couple of examples. I'll do one example and then I'll come back for a video. So the pre-work would suggest that this looks like this. x6 plus 1 to the power of half. That's actually what we're integrating. Let u equal x6 plus 1 du dx. Stay in the column. Okay. Now this time we're only going to multiply it by dx. And this time we're going to be selective. We're only dividing by 6. I'll let you work that out. But what that gives us is 1/6 du x5 dx. Dun, 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 dun. And the truth will set you free. Are you up there? I sure am. What about you? Are you up there? Yes, I am. Boom. You just moved into a whole new realm of mathematical horsepower. So both of those roosters are being subbed out. Okay? So we can rewrite du 1/6 the integral, and all we're left with is u to the half. That's the simple, trivial substitution. Wow. Wow. So that is the big deal about u substitution. You must take this from this subject into your futures. You must be able to do this. I suggest to you that you stay in the column before you rush back. I said I'd contrast that with what we do with chain rule, where we jump straight over and rewrite. Not yet. Do all of this in the column to find the things that you're going to substitute before you rewrite. Now we can do the integration. Up and under. So it's going to be 3 on 2. So divide by 3 on 2 is times by 2 on 3. And u to the 3 on 2 plus c. We're going to have a cancellation. That's going to be 1/9. 3 on 2 x plus 1 plus c. And that's your final result. Dun, 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 dun. Welcome to University Mathematics. We can do it. All right, that's enough for now. I'll be back soon to have a go at that one. See you soon.